we are joined by a representative from Green Delta. It is Jonas Hoffman. He is an LCA consultant and researcher at Green Delta, a company at the forefront of sustainability assessment and life cycle analysis. And today he will be talking about life cycle perspective of lubricants. So, dear Jonas, thank you so much for joining us. To start, could you kindly introduce yourself and share a bit about your experience in the field of sustainability and life cycle assessment?
Yeah, thanks, Daniel, for having me. Yeah, correct. My name is Jonas Hoffman. I work at Green Delta, which is a sustainability consultancy based in Berlin. And to my background, so in LCA, it's very common that you have a diverse background, mostly from natural science, but also engineering, also social parts. And for myself, I'm an educated chemist with a PhD in chemistry or molecular chemistry. So it's a bit unique in this field. And I have a secondary education in the field of sustainable chemistry management. So also still ongoing, but I'm conducting an MBA in this field. So I have a bit of overlap. And so at the end of the day, I'm not a trained LCA consultant because that's more environmental engineering, but I did kind of a side cut and went into the field. Yeah, and since then, I think it's beneficial because most of our employees actually have a bit of an overview. Yeah, and then what we do very often in our company in European research projects, we analyze the sustainability of novel products and technologies. So the Commission wants to be sure that novel technologies and products are actually sustainable, and also directly you highlight where there are potential issues. In one of our recent projects, which was called Primus, we looked into plastic recycling and using plastic recyclates for novel materials. And of course, it's a super complicated topic. And there we just wanted to highlight in which direction it's going and also to contribute with some data on sustainability.
That's great. You have an amazing background. Thank you so much for sharing it with us, and the way you are also improving and adding up new layers of knowledge. It's great to hear. Dear Jonas, you were saying that you even mentioned another project that you are working in, and that at Green Delta you analyze sustainability of novel products, right? What is Green Delta's role within CITOLab? And for our listeners, in case they are not familiar, what exactly is LCA or OpenLCA?
Yeah, thanks a lot. Good question. So within CITOLab, we are leading the work package on sustainability. It's a bit different compared to other research projects because this time, besides just assessing sustainability, which ends up in the report, we also bring our second big strongest aspect for Green Delta, which is developing software solutions and also tools. So what we're doing in this most prominently is we're trying to simulate the sustainability of lubricants in all its holistic way. So environmental, economic, and social. And it's rather complex. Theoretically, of course, at the end of the project, we could just hand in the report and say it looks like this. But what industry and what also policymakers want is actually that you speed up the process and start not to look, it's called ex ante, after the production is done. You want to predict the sustainability. And this is what we're doing at the end of the day. That's why Green Delta is here, because we are also providing respective LCA software, which is helping you to assess the sustainability of products with performing LCA. I will speak about LCA in a second, but just shortly with the software. It's already now roughly, I think, close to 15 to 20 years in this direction on the market. And it's open source software, which is very unique because in the LCA world, mostly the softwares are commercial. So you have to pay quite a fee, which is also a big barrier for companies or research institutions to use them. And within this, you can perform life cycle assessment, social LCA. And this will be also done, it will be the backbone in CITOLab to assess the sustainability. We'll couple it with other tools and going in this direction. Yeah, actually, what is LCA? That's a good question. So LCA, it is a scientific method to assess the life cycle impacts, environmental, social, and economic, of products, services, technologies. It is it has been around for some time, I think also 30 years plus more, and it's standardized by ISO. So if we conduct an LCA study, we look into the ISO and follow specific points. So it's very rigid, I would say, what you should do and what you should not do. Though it gives you enough flexibility to apply LCA to different cases. So yeah, and it answers very often the question, is A or B more sustainable? You can do an LCA and find it actually out with a lot of limitations sometimes, but you will find find information on this, or you look where there is a hotspot, so-called massive like aggregation of impacts in your supply chain, which is also very common. And with this, OpenLCA supports you. Talking about LCA, I know I explained or used the word a lot, but what is it at the end of the day? It's a systematic scientific method to evaluate environmental impacts of products, processes, services throughout the entire life cycle of them. So what does this mean? We look very often at specific products or technologies and look at the different life cycle stages, so-called. So very easy, we look at the raw material extraction, production, potentially the use phase, end of life. And within this, we assess the environmental impacts. Yeah, and for this, OpenLCA is a great tool because very often companies or researchers can use the tool to assess this whole life cycle and also look for hotspots, means where there's a lot of environmental impact happening for specific processes along their supply chain. But also if they want to compare it to other products, it's a good combination, especially in the research field. We want to know early on if a new technology, a new product is more or less sustainable than existing ones.
Thank you, Jonas. It's a great way to kick off our discussion. While I was listening to you and you were talking about the concept of life cycle assessment, can I ask you how the LCA, how life cycle assessment specifically applies to lubricants? Because you said that LCA is a scientific method that is, and it is standardized by the ISO, right? So it's a methodology, or it has a methodology behind. So how it specifically applies to lubricants, and more importantly, how is this implemented within the Safe and Sustainable by Design framework, the commonly referred to SESBD? So 2 questions.
Yeah, I hope I can answer both at the same time. So LCA and lubricants is a very, very interesting field because if we normally look at products, a lot of impacts are arising from their production, and some of them also at the end of life. So if we look, I just look around, for instance, a laptop. To produce a laptop, there is a lot of emissions happening during the production phase. Like you need to get the crude oil to get the plastic, you need to get the metals together. There is a lot of impacts on this. But laptops, they don't provide like a function in the logic lubricants do. So lubricants actually intrinsically aid to sustainability because they lubricate things, they reduce friction. This means without lubricants, we have a real issue in the world, having to use even more energy to do like to produce energy or to use it for transport. So we need lubricants. And hence in the use phase, which is very often neglected in LCA, is extremely relevant for lubricants. And this is something which is extremely special and makes it super challenging to work in this project. And also we analyzed the existing literature, and there is not so much harmonization going on what is defined a use phase very often, because it can be excavator, it can be transport, wind turbines, everything is moving and can be used there. So that's a big specialty. And the end of life, again, also like what happens after the lubricant is used. Sometimes they are emitted during the use phase. Sometimes also they can be recycled. Sometimes they're incinerated. So looking at this dimension is something LCA can do really good. LCA is there for you to explore the unexpectable. So if you ask me, is it better to recycle or emit directly? We have to very often look into what in our studies and our OpenLCA and to investigate a bit more. So that's very often interesting. And connecting this to SSBD is even more interesting because the whole SSBD world, so the Safe and Sustainable Design Framework, where C2Loop is also placed in and is working on, is the current cases which are there doesn't focus strongly on this use phase, where the performance of the material is very important. In LCA, you define very often, and I think that's something which maybe the listeners can learn today, on a functional unit. So you define a product not by a kilogram of something, you define it by functionality to make it comparable. If we look, for instance, at food, it is, for instance, you can say, is it better to eat meat or is it better to eat salad? I mean, the comparison per kilogram, for sure, go for the salad. I mean, it has, but normally then you go for calories and say, look, if we make it calorie based, then it's a fair comparison because you need way more salad. And bring this to lubricants and to SSBD, we need to look strongly on the performance, because if we have a weak performing lubricant, which also requires a lot of exchange of the oil, is actually then the worst performing environmentally, because you need to substitute it a lot. And so it's complex, and at the moment this use phase is not really strongly looked on in most of our LCA studies. Also we do at our company, it's not very often looked on, and also within SSBD at the moment it's not really focused on, and yeah, there is no real harmonization, so we will develop it in C2Loop.
It's very interesting, the fact that when you talk about the life cycle assessment and you talk about the lubricant's journey itself, you look at the performance and not strictly at the final result of comparing the mass. So in this sense, what are the key stages of its life cycle from production to disposal? Where do you see the biggest environmental impacts occurring? I'm asking because you have also talked about the use phase, which is crucial and very important regarding the performance. So my question is, where do you typically see the biggest environmental impact occurring when looking at the life cycle itself?
Yeah, thanks a lot. So the generality of life cycle stages, which we identify normally, is the extraction of raw materials, the formulation itself, packaging, distribution, the use phase, and the so-called end of life. So the disposal, recycling, different options can occur. So our preliminary results show that the use phase is drastically important depending on the type of lubricant, but some of them are directly emitting the lubricant, but also the efficiency of the lubricant plays a big role. As I mentioned before, the less lubricant you have to use to do the job, so this is the functional unit at the end of the day, the functionality, the better it gets. So if we improve performance, we most likely end up having lesser environmental impact. So that's the kind of, there is a rule of thumb. It's derived from industry. There is 1/3 of the emissions come from production, so raw material extraction, formulation, and 2/3 come from use phase and end of life. It's not very general, but it helps to understand, because in LCA we look very often, and also for so-called pro and con footprint, which is something related to LCA. We very often only look on the production, because this is what industry has in hand, and hence they don't go further. But in this case, it's very interesting because the emissions happen at the end of the life cycle. So that needs to be considered. And the whole thing is called life cycle thinking. It's also, if you produce a lubricant, you need to think, is it recyclable? Which is happening not at your facility, but with the end user most likely, or a re-refining manufacturer. And this is very important to think about if you design, and this is with SSBD, the logic, the moment you design it, it should be safe, sustainable by design.
That makes sense and actually connects very well with what we were talking before, in which looking at the design to get the best efficiency, because that is the efficiency of the lubricant is on the table, right? but then looking at the use phase and the end of life, investigating the design phase to make it more efficient is the best way to go through. What are the methodologies and metrics that are commonly used in LCA specifically for lubricants? Are there any?
Yeah, thanks a lot. Very good question. So we are lucky and unlucky at the same time. In the LCA world, all LCAs are, or most of them are based on the ISO 14040, which is the generic standard to do LCAs. So you need to follow these guidelines or these steps to do a proof or like a sound LCA at the end of the day. For lubricants, in the lubricant sector, industry relies still heavily on product carbon footprinting, which is also another ISO. It's the ISO 14067. It's also called PCF. Hence, they only look at carbon. So everything is related only to global warming, climate change and global warming potential. And you look for greenhouse gases at the end of the day. But if LCA has the potential to look at other dimensions also as acidification, land use, to stop this trade-off, because sometimes, we might discuss it later, if you go for more bio-based materials, you reduce the fossil carbon in your product, but you have maybe trade-offs by using more land, using more fertilizers, and LCA is a really good tool to assess this. So yeah, with the PCFs, the ones that exist in industry, there are several methodologies around. There is quite a new one for PCFs for RTEL, UIEL. It's at the end of the day, those are associations from the lubricant sector, and then they provide harmonized PCF guidelines. So we can't really use them because we're doing LCAs. We can be inspired by them, but it's slightly a different approach they take. So we'll be inspired by it, but that's not all. There is something upcoming for another. Now it's a lot of acronyms for EPDs, environmental product declarations. To do those, which are used very often in construction sector, you need to have a harmonized way to make your LCA studies. And there is a development going on that they will produce something, and we can also feel inspired by this. But the rest, that's sometimes the problem with LCA, gives you a lot of freedom to not harmonize the LCA. In C2Loop, it will, because it's we build it, it will be harmonized if one client at the end of the day or one user uses the platform and another one, they will have comparable results. I think that's most important to increase the uptake. What we do at the end also is to analyze the impacts. I mentioned already there is more than just carbon emissions. We look at something called the environmental footprint method, which is provided by the Joint Research Center of the European Commission. And there it's very good organized in a way that you try to not leave out any environmental impact category you can imagine, so that we will not, again, these trade-offs. So I think there are 17 categories, going from water usage to ionization, radiation, to human toxicity. Yeah, and that gives us a broad picture actually already. So we use this. I think that's the state of the art at the moment in Europe. Yeah.
Yeah, it's great to hear you saying that we can also look into these specific categories provided by the European Commission that provides a very broad picture, and the fact that there are already environmental product declarations that allows to have more or less harmonized guidelines. But of course, that when we have specific use cases, we want as well to be as free, or be using as much freedom as we can in LCA to define parameters, because that is also important in new product development as well. In fact, dear Jonas, when you were talking about these metrics, they are relevant for comparison purposes, right? So how do at this moment, what is your knowledge about how do the bio-based lubricants compare to the conventional ones in terms of their environmental footprint, considering that there's efficiency and there are metrics associated with production, use, disposal?
Thanks a lot for the question. So, um, our first initial study we did with an intern of mine, we tried because to understand the whole picture for fossil-based lubricants, we have a bit of data, not so much, but a bit. And for bio-based, there is no data. So we have to model it ourselves. That's part of the LCA practitioner job and also part of my research. And once we modeled like a bio-based lubricant from scratch from like scientific publication, we saw that it's performing worse in all the categories. And that's of course a surprise, which is a bit revealing, but that's where the methodology in LCA and SSBD is lacking behind. If you go to the lab and design something new and compare it to something existing, it will always show that you need to stop at this stage, and it doesn't. Your novel product is not more sustainable than the existing one. This has to do with long-term effects, like the existing industry is already there. Everything is optimized. Every byproduct is used. It's highly efficient. For
Mm-hmm.
bio-based, if I look, for instance, at a soybean-based lubricant, I mean, you need to produce soybean oil. The waste needs to be discarded off. They can't be used somewhere else. They cannot be incinerated sometimes. They need to be landfill. So it is looks complicated. But we are positive if we do the calculations correctly that in some cases the bio-based material will have advantage. But here it's really important to do full life cycle LCA because in some also in the product carbon footprint methodology, you are allowed to give like a negative score for taking up carbon dioxide because it's in the soybean, for instance. And then later on it's released after the life cycle of it. And this advantage is actually shown there, and fossils don't have this. But in the methodology we use from the commission, this is not accounted for. So we need to have a look into this. And I would always say in LCA, it depends. So we need to do a study and and analyze it in depth.
Yeah, it's not straightforward. Each case needs to be analyzed. So moving to SCSPD, because we have been talking from both topics, how does this framework influence the way lubricants are designed, produced, or disposed? And how can a project like Citolub help with that? Because Citolub works and also focuses on the SCSPD framework as well.
Yeah, very good question. Also, in this way, at the moment, we need to consider that the lubricant industry is still relying on product carbon footprinting and is not yet at the moment where they use LCA. So if you go to a lubricant meeting in terms of like Expo, I have been recently, they for sure they don't know what SSPD is at the moment. So they are not really aware of this because they are still struggling with other things. And I think in the future it has a huge potential. So also the lubricant industry is feeling the pressure, like economically and also from environmental point of view to reinvent. And I think the SSPD is a great tool to do this if they early on want to analyze if their products, if they're with new regulation, you need to be careful if you still use certain products. And if they want to substitute those, the SSPD framework is really, really helpful to do it. For the safety part, for sustainability, as we discussed, the performance is not well integrated yet. So this takes a bit of an approach. But though I think it's this idea and this guidance is a great approach to support also companies to phase out harmful materials at the end of the day.
Yes, yes, and makes sense. And you were talking about the push that the industry will have environmentally, but there are also regulations. What are the main challenges in implementing the SCSPD principles in lubricant manufacturing today?
Yeah. So if you talk about the principles, it is like we have an SSPD 9 principles, which kind of design or tell you how you should design your material. But for instance, they say use bio-based materials. And as I said already, in LCA, we really assess if this is better or not. So there should be studies being done prior using it because there's another thing I wanted to mention, we can make something bio-based, but very often, if it's not hardly or it's not strongly modified, those things are not recyclable anymore then because they are biodegradable. So it's excluding itself. You can't recycle it, and recycling is theoretically is a good approach normally to keep the carbon in your life cycle. So this would exclude itself. So there is a problem with this.
You need more raw material, right, to constantly fit in the system.
Yeah, for instance, like this, it's good, for instance, if we make things biodegradable, because that's also an SSBD idea, if the material is intrinsically released to the environment. I mean, then it's perfect, because at the moment, if you put a mineral-based oil lubricant into the environment, for sure it doesn't degrade very fast, and there could be secondary effects which are problematic.
Yeah, it's understandable. The overall landscape, it's a bit complex. And of course that when you were saying earlier that we always need to look as well to the performance, to the disposal, then we need to be very careful and always keep in mind that when studying and developing alternatives to the ones already existing in the market, we will be surprised or not. It depends on the perspective, of course, but there is this element of surprise in which we think, oh, this we can label this as bio-based, but since the overall structure is not harmonized, there's more investigation that needs to be performed to design them to be more safe to the ecosystem, right? From a manufacturer's perspective, since you work in doing these calculations, simulating the LCA, from a manufacturer's perspective, how can they effectively reduce the environmental footprint and improve circularity in the lubricant supply chain?
Yeah, so as I said before, the trick is, of course, we need to do LCAs, and as a scientist, it's very hard to say A or B. But the trends we see is try to design it in a way that it is recyclable. There is a trends going on with re-refining, that actually reusing in that case fossil carbon is a good intermediate step to keep things alive at the end of the day, or to keep the material in the loop. So circular approaches, circular economy is a good approach here. What else? I mean, what you can easily do is very hard to say. I think everyone needs to also focus on themselves and look what they have as hotspots in their supply chain. So you can
Yeah.
use databases for this, also literature reports to understand what is the issue of your products or not. I understand, and I've been recently in contact with a lot of lubricant industry representative. The budget is tight. It's a
Yeah.
complex field, but we asked them also to measure, actually first to start to measure their sustainability with using LCA, because PCF gives a limited scope. It has the advantage as a lot of first-hand data, but though it is a limited scope at the end, and to try to push more for LCA is of course one of my messages, but um, C2Loop and its platform will support for sure in this field, and we are doing right now a really hard job so that afterwards easier for everyone to assess the sustainability of lubricants.
Yes, and the fact that you're talking about the databases, the need to have these inputs that almost to fit in like a library, and sometimes a tight budget to effectively look into the supply chain. This might be delaying the velocity in which things enter the market. Is this one of the biggest challenges in applying SSBD to lubricants, the development phase, the investigation towards new products or recyclability or biodegradability? What is the biggest challenge itself in applying the SSBD to lubricants?
As for now, what we can see is data availability is the biggest problem. So if you look in one of the most competitive LCA database you have for lubricants, there is one data set, and it's an artificial data set. A lubricant like this doesn't exist. It's just to at least have something, but the rest at this stage there is not a lot of data. There's new data coming up on the market for a bit more specific to lubricants, and hence there is something going on. But for sure, data availability is also what we see in our research project. I think now we have to spend the next 3 months just to model the data gaps to fill them. In the future, of course, AI will cover this a bit more, and we're already working on it. But for now, it needs a trained chemist to understand how things are produced and to fill the data gaps. It needs an engineer to understand the performance and an environmental engineer to understand the end of life of these materials. So yeah, this is a bit the challenge for us at the moment. And further, I think I mentioned before, the scalability is a problem. So if we do something on a kilogram scale, for the purpose of proof of concept, and later on we compare it to something which is produced on a multi-million kilogram or kiloton scale,
Yes,
you always have problems.
Yeah, scaling up the results, right? Dear Jonas, one specific question regarding the LCA and the environmental side, because at least for me and maybe for most of the listeners, from our followers as well, it's very common to have this idea that LCA in the context of SSBD as well, it's very focused on the environmental purposes, on their environmental side. We know that SSBD, LCA is an exercise that can be done and exercised into more dimensions than just the environment. How are the other dimensions, like the social and economic aspects, respected in LCA? Are these more or less advanced than the environmental component or not? Is there more lack of data? How is the landscape when we compare these three modules, if we can put them like that?
Yeah, very good. So it's a very good question. If we talk about sustainability, we always say holistic sustainability in our like approaches. This is indeed environmental, economic, and social. Because as what I explained before with the PCF, that you only look at one thing and then you have trade-offs in other dimensions, is the same for environmental, social, and economic. We are indeed very strong as our company in these fields. So for the social part, in social LCA, you can assess social impacts. The data there it's still a young field, so it's still emerging. There are basically two really large databases for this to conduct, and one is owned and produced by our company. So we're really lucky we have firsthand decision making on how this develops, and this data is based on public statistical data from countries but also sectors. Yeah, but I think it's still a way to go, and it's less mature than environmental LCA. It's also harder to understand, but where is it really beneficial is to understand supply chains, to understand we now model the whole life cycle for the environmental LCA. We know already the data, and we can also use it for social LCA, and then you can also have a look into this. So it is important, because also talking about, we talk about bio-based materials, and we can also think about that some of these are produced in monocultures, some are in other countries. So of course we want to know in the sector what is the problems, workers' rights, what is like also maybe literacy or child labor. This is important to understand, and there we have a database already can be used called Silka, and it's also favored by SSBD. And for the environment, for the economic sustainability, we look on the cost side very often for production and labor cost, but also what we're trying to do right now is so-called the externalization of environmental impacts. Sounds fancy, but it's at the end of the day, all the emissions we have for the life cycle in terms of environmental emissions go on the burden of the nature. And there is a scientific method way to quantify it with a number. So at the end of the day, the cost you produce to the environment can also be put in this dimension. So yeah, it's going on. We're working on it, and in C2Loop it will be also further developed for lubricants.
Yes, to make it more robust. And then looking towards the future, how do you see the role of digital tools and AI in optimizing lubricant use, and if possible, of course, waste reduction?
Yeah, a very good question. In this direction, we are currently, it's helping a lot with filling data gaps at first, especially in our field, in the LCA field. So we are relying on already partly on it. For the future, I think because SSBD is so complex, you have safety dimension, sustainability, and also in C2Loop, we have the performance dimension. We need to think about having kind of a metrics to say what is the best. And if you ask me what is the best, actually, I don't know. It's very complicated, but AI has the potential to solve this riddle and then also to potentially suggest new structures based on what is there already existing and knowledge. So I think it has a lot of potential. It's still not used too much in industry, but for such a research project, we can use it a lot and will benefit a lot for defining new formulations for lubricants for sure.
Yeah, that is great. Thinking about how AI can accelerate or assist in accelerating the development part is actually of great help. And the way that technology has been assisting the human mind as well. So it's great. Finally, dear Jonas, if there was one message that you would like our listeners to take away about lubricant sustainability, what would it be?
Yeah. So for lubricants, I think it's relevant to know that they intrinsically contribute to sustainability by reducing friction and wear of other materials. And this is very exotic for LCA. So keep in mind that lubricants themselves contribute to sustainability, though they need to be assessed, of course. But that's something I think it's very impressive to see. And also that the use phase and end of life is determining the whole, basically most of the life cycle for lubricants, and which should be focused on in the future a bit more.
That is a great message. I have to admit that I was not expecting you to say that. The first sentence that you said, focusing on the fact that for us, we need to look at the lubricant as the product that has been helping us being sustainable in the processes themselves, because the lubricant themselves, the role on the industry by decreasing friction, it allows us to spend less energy and so many other things. So it's a great way to introduce this message to our listeners. Dear Jonas, it was a pleasure to have you with us today. Thank you so much for sharing your amazing insights with us on Drop the Knowledge by C2Loop. I hope we can get another opportunity to have you here with another topic. So thank you so much.
Yeah, thanks for having me.
And also, before ending this episode, I need to do a special thanks to our listeners. I hope you can keep in touch and follow us on social media and our website as well. And stay tuned for the next episode.